Welcome all. In this lecture, we are going to deal with another new example, that is example number 9. So, with the help of Routh-Hurwitz's criteria, comment upon the stability of the system having the following characteristic equation. So, in this question, we have to find out that the system is stable or not, and in this question, we are given with a characteristic equation that is represented as s to the power 6 plus 2s to the power 5 plus 8s to the power 4 plus 12s cube plus 20s square plus 16s plus 16 is equals to 0. So this is a characteristic equation. In this question we are going to check stability. So first of all we have to form a Routh array. After that we have to check for that the system is stable or not. So let's first write the even coefficient of even power of s. So the even coefficients are s to the power 6, s to the power 4, s to the power 2 and s to the power 0. So the coefficient of s to the power 6 is 1, coefficient of s to the power 4 is 8, coefficient of s to the power 2 is 20, coefficient of s to the power 0 here is 16. Let's write the coefficient of odd power of s, that is s to the power 5 coefficient is 2 here, s to the power 3 coefficient is 12 here, s to the power 1 coefficient is 16 here, remaining no coefficient is remaining, so we will simply write 0 here. Let's form the Routh array. So here the highest power of s is s to the power 6, so it will come here. After that s to the power 5, then s to the power 4, then s to the power 3, then s to the power 2, s to the power 1 and s to the power 0 finally. Since the highest power of s is even, that's why we will write first the even coefficient of s powers. So 1, 8, 20 and 16. Now it is an odd power of s, that is 5. So we will write the odd coefficient of s, that is 2, 12, 16 and finally 0. Later on we will fill all the entries of this Routh array by doing the cross multiplication. So let's do it. First of all we will take the 1 and 2, 8 and 12. So 2 will be multiplied with 8, 2 into 8 minus 12 multiplied with 1, 12 into 1 whole divided by 2. So we will get 2 here as a result. Moving on to the next column, that is these two elements 20 and 16. 2 multiplied with 20 minus 16 multiplied with 1 whole divided by 2 only. So we will here get 12. After that we will take 1, 2, 16 and 0. So 2 multiplied with 16 minus 0 multiplied with 1, we will again get 0. This whole term will be divided by 2. So we will get 16 here. Writing the results in the Routh array, 2 that will be written here, 12 will be written here, 16 will be written here, remaining no term for further multiplication, so we will write 0 only. Later on we will again do the same multiplication. So 2 multiplied with 12 minus 12 multiplied with 2 whole term will be divided by 2. So we will again get 0 here. moving on to next column. So 2 multiplied with 16 minus 16 multiplied with this 2. Whole term will be divided by with this 2. So we will get 0 here also. 0, 0. After this 2 will be multiplied with 0. 0 only. 0 will be multiplied with this 2 minus 0. So the result will be 0 only. And remaining no columns are there, so next result also be 0. You all notice that this complete row become all 0 row. So this is type first variety of question. In this whole row becomes 0. So in this type of question we have to form an auxiliary equation, and the auxiliary equation can only be formed on the basis of the row which is present just above the all 0 row. So the row which will help us in forming the auxiliary equation will be this row. On the basis of this row we will only perform the auxiliary equation. So the auxiliary equation is denoted by A of s. Here the highest power of s is s to the power 4. So the coefficient, that is 2, will be combined with s to the power 4. So it will become s to the power 4. Then we will write 12. Even power of s in the decreasing order will be s to the power 2. Then plus, then we write 16. Then in the decreasing order, even power of s will be s to the power 0 equals to 0. So we can rewrite the auxiliary equation as 2s to the power 4 plus 12s square plus 16. This is our auxiliary equation. After this, we can differentiate our auxiliary equation. So d by d of s of a of s will be 8s cube plus 24s, and the constant differentiation will be 0 only. So this is our new equation, by the help of which we can perform the Routh array criteria. So the new Routh array will just look like s to the power 6, s to the power 5, s to the power 4, s to the power 3, s to the power 2, s to the power 1, s to the power 0. 1, 8, 20, 16, 2, 12, 16 and 0. Then 2, 12, 16 and 0. After this, based on this equation, that is 8s cube plus 24s, we will write the coefficient here. So the highest power of s is s cube, and here also the highest power of s, which is all 0 row, is s cube. So we will write the coefficient of s cube here, 8. After that we will write 24 next to 8. Remaining no elements are there, so we will simply put 0 here. So this is our new Routh array. After performing the cross multiplication and filling all the values, we will get 6, 16, 0, 0, 8 by 3, 0, 0, 0, 16, 0, 0, 0. After further calculations by performing the cross multiplication method, you will get these entries only. To reduce the time of the video, I simply put all the values which I have calculated earlier. Since our Routh array is now ready, so we need to check that the given system is stable or not. For checking the system stability, we have to check the first row of the Routh array. So here in the first column of the Routh array, 1 is positive and 2 is positive. So there is no sign change. 2 and another 2 is also a positive. So no sign change. 2 and 8 both are positive. Here also no sign change. 8 and 6 are positive. So no sign change. 6 and 8 by 3 is also a positive. No sign change. 8 by 3 and 16 is also positive. So we can say that total number of sign change is equals to 0. So we can say that no roots lies in RHS of S-plane. Since none of the roots lies in the right hand side of S-plane, so we can simply say that our system is stable. So this is the stable system. Thank you. If you like my videos, then press the like button and subscribe to my channel.